Now, another thing that's very important when we think about sound waves is that the fact that the sound waves depend on temperature. The higher the temperature, the quicker the speed of the sound. The lower the temperature, the lower the speed of the sound. And we will discuss that today. So there are three main scales of temperatures used around the world: Kelvin, Celsius, and Fahrenheit. You may have heard of the Celsius scale. Anybody travel to Europe or any other part of the world? Not yet? Maybe planning to go on the go trip? Are you planning to go abroad on the go trip? Raise your hands. Excellent. Where are we sort of planning to go? Italy? Africa? Both places, yeah? Ireland. All three of these places, what you will notice is that they use SI units. So in America, you use the Fahrenheit scale. When you go anywhere abroad, they will use what is called a Celsius scale. So this is the perfect time to learn the difference. So the difference between a Fahrenheit and a Celsius scale, a Fahrenheit and a Celsius scale, is that water boils at 100 degrees Celsius, whereas a water boils at 212 degrees in the Fahrenheit scale. The normal body temperature is 37 degrees in the Celsius scale or 98, 99 degrees on a Fahrenheit scale. US and one other country are the only two countries in which a Fahrenheit scale is used. Everywhere else in the world pretty much uses the Celsius scale. So 50-degree temperature is very, very, very high. And water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. 20 degrees is important to remember because 20 degrees is generally considered room temperature. Most science experiments, when they say room temperature, they mean either 20 or 21 degrees Celsius. So here's what we need to remember. Room temperature is about 21 degrees Celsius or very close to 70 degrees Fahrenheit. So whenever scientists talk, they either talk in a scale that's called a Kelvin scale, or they will talk in Celsius. Kelvin is a very particular scale in which you add 273 degrees to whatever temperature you have in Celsius. We'll take you to the Kelvin scale. Another very interesting phenomenon is this one. It's called absolute zero. What is absolute zero? All molecules in the world have a little bit of vibration in them. That vibration depends on temperature. So at the absolute zero temperature, all vibrations for all materials that you see around you stop. So what does that have to do with what we are talking about? Speed of sound is highly dependent on the temperature that is around us. So have you ever noticed the fact that it becomes very, very quiet when it's really, really cold? And there is a very physicsy reason for that. And the reason for that is that sound actually travels slower when it gets colder. And the formula is this one, by which we can tell by how much the speed of sound changed with respect to temperature. And that is a good number to remember. So at 0 degrees, the speed of sound is 331 meters per second. So another way to think about it is that sound travels 331 meters in 1 second. Whereas at room temperature, the sound will travel at 343 meters in 1 second. And that is a difference of, give or take, about 12 meters. So just changing the temperature from room temperature to 0, sound actually travels less distance in 1 second. And 1 second is how long? 1/1000? So it travels 12 meters less. Okay, so why does this happen? So what you have to do to find the temperature at, say, 5 degrees is, at 5 degrees, speed will just be 331 plus 0.606 times 5 degrees. What will be the speed at, say, 10 degrees Celsius? 331 plus 0.606 times 10. Can someone tell us the answers to those questions? So the speed of sound at 5 degrees and speed of sound at 10 degrees. And speed of sound at 0 degrees. That one is 331 meters per second. Yes? There we go, 337 meters per second. And for 5 degrees, 334. Okay. What do you notice? As temperature is going up, what is happening to the speed? It's going up, right? So as temperature goes up, speed of sound goes up. Why does that happen? That happens because as temperature increases, the vibrations increase. So the molecules vibrate faster. When molecules vibrate faster, they hit each other more. And so the sound has more distance that it can cover. So here's the moral of the story. As temperature will go up, the speed of sound will go up. That is why it feels very quiet when it gets very cold. Okay, here's another something I would like you to write that down. To convert the temperatures. Vice versa, in order to convert the temperature, say, if it's given in Celsius, use this formula. So if the temperature is given in Fahrenheit to you, use that formula. If the temperature is given in Celsius and you're being required to convert it to a Fahrenheit, use that formula. I can tell you, in most scientific solutions, you will be asked to convert the temperatures to Celsius, not vice versa.